Let's move on to squares. Now, squares can be used in lots of different interesting ways, and I'm going to build in some animation after showing you how to draw basic rectangles. Rectangles take 4 what we call arguments: their x position, their y position, their length, and their width, whilst the circles we were using previously took just 3, their x position, their y position, and their diameter across. Now, we can do all sorts of interesting things with rectangles, but let's just start by drawing a basic one. So we'll say 0, 0, so top left-hand corner, and let's give it a size. In fact, let's actually give it a variable for its size, right? So we'll say var cell, okay? And it's going to be 40 across. So now, instead of the word cell, just read the word number 40, okay? There we go. So we've got this. What would we do if we wanted to draw a whole line though? Well, we'd kind of need this to loop, but with some slightly different numbers for its x position, wouldn't we? And to do this, we're going to use our first loop. And this is called a for loop. Here's how we write it. We write for var I equals 0, semicolon. I is less than, in this case, 10, and I plus plus. All right, and we need to put some curly brackets around this, and then I need to explain to you what on earth any of this means. So, it's very, very simple. There is a variable called I. We just use this because it stands for integer, which is a whole number, but it could be anything. And what we're saying is that I starts at 0, and I will stop when it gets to less than 10. So if it gets up to 10, it'll stop. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. And each time I is going to go up 1. So what it's saying essentially is whatever happens inside this loop, this for loop, is going to happen 10 times. Now we look at this rectangle and we don't see any difference. Why? Well, because nothing's changing, is it? Because these numbers are raw numbers. Let's change this for I. We can see that something is happening. What's happening is that the rectangle is being moved by 1 pixel each time as I becomes 0, 1, 2, 3, 4, so on. Let's see what happens if we times I by the cell. There we go. And in fact, if I change this to 0, we can see that we have a line of rectangles. And this is actually a really great place to start. And in a bit, I'm going to show you how to draw a board using something called a nested loop. But I was thinking of an idea where we could maybe draw some rectangles that are inside each other. So let's just think about the maths of that. So what we want is a rectangle that's as wide as the canvas, and then the next one's a little bit narrower, and the next one's a little bit narrower. So how would we do that? Okay, so here's how we're going to do it. We're going to create a very wide rectangle to start, and the way that we do it is we say its width is going to be 400 minus the cell. You could say, oh, 400 minus 40, right, so we've got 360 by 360. But here's the trick. We say minus I times the cell. So when you first start, it's 0, right? I is 0, 40, 0 times 40 equals 0. So it's 400 minus 0. In fact, I'm going to make this even clearer by making these 401 wide so you can see it. So let's think about the logic. We've got 400 minus I, 0, times 40, 400 by 400. And then if I create another one, we've started to get some squares. In fact, let's just create 10, just like that. Okay, this is good. In fact, this is really interesting, but this isn't that kind of square and square and square and square and square and sort of thing. We're getting there, we're getting real close. And I like this I times cell thing. Let's try this here as well. Okay, it's kind of done the opposite. It's not quite what we were looking for because let's see what's happening. Well, it's getting moved over right. So these squares are getting smaller, but they're getting moved too far over right. In fact, this might actually be a really good time to just bring back into play our old friend, x and y. All right, so let's have x colon plus mouse X. That's actually all we need for this one. And I'll just say mouse X, mouse Y. So see, that's not quite working. In fact, there we go. If I put this in front, which will work absolutely fine, and outside the for loop. Okay, so that is our position right now. It's 40. We kind of want it to be 20, don't we? We want it to split the difference. We want to move over this square from 40 to 20. We want to move this one from 80 to 40, and this one to from 120 to 60. So you're getting it, right? These are all halved. Yes, so we want to halve these positions. So let's say I times cell divided by 2. Okay, now we're getting somewhere. And let's also divide that by 2. And what we've got is the square and square and square in. But we're not quite done yet, because I think we can actually do some really interesting things with some animation. So I'm going to create a var called num equals 0. And I'm going to replace this with num. And in fact, let's just change that to 10. So if I change that in different numbers, it makes more or less squares. Now, let's automate it. So we could say num plus equals 1. Start at 0. So it's going kind of fast. Let's slow it down, 0.1. All right, it's drawing. And then it goes out and then it disappears again. So we need to limit it again. So we could say if num is greater than 10, then num equals 0. Let's see what happens. This is really cool. I really, really like this. This is moving in and animating and it's working great. And what if we could just play about with a little bit of, make it a bit more trippy. Let's add some stroke weight to it. So we're going to add stroke weight like this. And we're also going to call it num. And now you can see it's getting thicker as it goes in. So that's a really nice bit of animation. And if you turn it up a bit, and I do have to put a little bit of a trigger warning for anyone who has any seizures or anything like that, or has problems with flashing. So I'm going to show something which moves quite fast in 3, 2, 1. Here we go. And there you go. Really interesting, little bit of psychedelic art. Let's go back to how it was. And we've just done that by using some variables and using a little bit of thinking inside of this for loop. So in the next video, I'm going to apply that to some different shapes. But in the meantime, try this out yourself and make your own changes and play about with speed and shape and position and see what happens.